Good morning, CP Pre-Calc. And what we are doing today is we are beginning our section on conic sections. Now, what we have here is you watched the video above that discussed what a conic section is and how a double napped cone is used to form conic sections. Now, what I have here is just a little visual, another visual. And you'll see this right here, over here, this is our two-dimensional plane. And that's a two-dimensional plane that is cutting through my double napped cone. And you'll notice in this case that on the double napped cone, you see the ellipse. And also on my two-dimensional plane, my X and Y coordinate plane, you also see that ellipse. All right, guys? So what we're going to do is if you take a look at here, the plane that's cutting through is going to be my X and Y, and the Z is going to be my the axis that's going up and down. All right. Now what I can do here is I can rotate. You can see I can animate this. So it changes the shape of what type of conic section that I obtain. And sometimes I might have a partial ellipse. Sometimes I might have a full ellipse. Now here, this is a full ellipse for that conic section. Now, if I animate, I can move things. I can rotate. Now, if you look here, as I rotate here along the y-axis, you are going to see that right now my conic section over here on my two-dimensional plane is a circle. So the two conic sections that we talked about are ellipses and circles, all right? Now, obviously, there's a couple more conic sections that are possible. Now, if we take a look at this, I'm rotating that, see what happens. I'm rotating it. It keeps on going, keeps on going. All right. Eventually, wait a minute, it hits both cones. So if we have a conic section that intersects, the plane intersects both cones of a double napped cone, that means right here, what we have is a hyperbola. All right. And you can see on your two-dimensional coordinate plane, the hyperbola. All right, guys. And we've already worked with hyperbolas in this pre-calculus year. We've worked with them with our rational functions. All right, so that is our one of our other examples of a conic section that is formed. Now, we can also, if we animate, if we draw our conic so that the line is parallel to one of the sides. So let me rotate it to see if we can visually see that, where I want the line to be parallel. If you look here, right here, if these two lines are parallel, then what I'm going to have, if my plane intersects my cone, and it is parallel to one of the sides. So as you see the arrow right here, if it's parallel to this side, the plane, then it would form a parabola on my two-dimensional coordinate plane. All right, guys. So that's just some additional visuals for you after your video on conic sections. Now we're going to start with one of the basic conic sections. We're going to talk about circles. Now, if you look here on this is also on the note sheet that I have posted. The definition of a circle is a set of all points in a plane that are equidistant from a given point. That the given point is called the center. So this is the key word that I like to talk about, equidistant. That means equal distance. So when I look at my circle, I have a center. Okay, guys, let's put a center to my circle. All right. And that equal distance from the center to any point on that circle is called my radius. All right. That's my equal distance. So if I think about that, all right, guys, if I think about that, let's make that a little darker so that we can see it a little more. So I have the center and I have my radius. Okay. That radius is constant, meaning that no matter where I go from the center to any point on that circle, I will get the same distance. That is the equidistance that they're talking about. The length of that radius is your equal distance. So let's talk about distance here when we think about anything. Let's say the center of my circle, I'm going to say the center of my circle is HK. Now, the center is constant too, because the center of the circle will always be HK. It will be whatever X and Y coordinates my center falls on. However, these points on the circle are going to vary. So I can have a point here, I can have a point here, I can have a point here. That point on that circle can vary. So when we have something that varies, we use variables X and Y because the radius represents the distance from the center to every point on the circle. So since we have infinite number of points on the circle, that point is going to vary. Therefore, we're using our X and Y variables. Now, when we talk about distance, let's recall our distance formula. Okay, So I have the square root of x2 minus x1 squared plus y2 minus y1 squared. This is our distance formula. We're going to use this distance formula to derive the equation of the circle. Well, we just said the center was hk, and any point on our circle, so my center is hk, and any point on my circle is going to be xy. And the distance is represented by that radius. So let's take a look. Let's plug in our values. So if I want to plug in my values here, I can say, I can say r, because the distance of the circle that stays constant is the radius, is equivalent to the square root. So let's pick a point. I'll do my x. We'll label this one as x1. So we'll do x minus the x value of my center plus y minus the y value of my center. So I use my 2 points. And then the only thing I'm going to do to derive that equation of the circle is I'm going to get rid of that radical. To get rid of a square root, I do an inverse operation. The inverse of square rooting something is squaring it. So I'm going to square both sides. To get r squared is equivalent to x minus h squared plus y minus k squared. This here, guys, this is the equation of my circle. So that is the equation of my circle. We just derived it from the distance formula because this definition of a circle is the equal distance, the set of all points that are equal distant from a given point, the center. And that's why the center and the radius are very valuable in our equation, because the center is that given point and the radius represents that equidistance. So now let's go down to writing that down. So when we talk about that's the equation of the circle, so you're going to see it just like we just had it. You're going to see it like x minus h squared plus y minus k squared equals r squared. That is the equation of a circle. Now, if you have a center of 0, 0, that 0, both those points, the values of 0 would go in for h and k. So this would be even simpler. It would be x minus 0, which would just be x squared, plus y minus 0, which would just be y squared, equals the radius squared. So that's the formula we would utilize if we had the center at 0, 0. All right, guys, so let's take a look at what we just talked about, and we're going to go over some problems. So let's take a look at number 1. In number 1, it says identify the center and the radius of each circle, then graph the equation. You'll notice that in number 1, our center, since we're not subtracting anything from our x or our y value, your center would be that 0, 0. Now remember, the equation says x squared plus y squared equals r squared. So your radius is not 25. R squared is equivalent to 25. So what would r be? Now remember, radius represents distance. Distance can only be positive. So r can be, in this case, r can only be 5. Okay, we don't have to worry about that -5 because when we talk about distance, distance must be positive. So now if we're going to graph this, guys, I'm just going to go and I'm going to put a point at 0, 0 for my center. All right, it might be easier if I do it in there. I do a point at 0. And then I count out. I go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Count 5 in all directions. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And guys, it's going to be hard for me on this to draw this, but just draw that circle the best you can. All right, guys? So that would be my answer to number 1. Now, number 2 is different because I do have an h and k value. But what I want you to remember in number 2 is that you're subtracting h and you're subtracting k. So it's x minus h, y minus k. So you're asking yourself, what am I subtracting from my x? What am I subtracting from my y? So if I look at that first problem, if I look at that x, what am I subtracting from my x? I am subtracting a positive 3 from my x. Now you have y plus 1. Now again, you're asking yourself, what am I subtracting from y? Well, in order to have a plus 1, you need to recall that y plus 1 is the same as saying y minus a negative 1. In order to have that positive in the inside is you're subtracting its opposite. So you're subtracting negative 1. So therefore, what am I subtracting from y? I'm subtracting negative 1. Therefore, k is equivalent to negative 1. Now again, remember, r squared equals 12. All right, guys? That means r is equivalent to the square root of 12, which if we rationalize would be 2 root 3. Now, guys, let's think about that, okay? I'm going to put that in decimal notation. And I'm going to put in decimal notation so I can estimate approximately how far the length of my radius. And R is going to be approximately 3.46. So what you're going to do when you graph this is you're going to graph approximately around 3.46 or 3.5 for your radius. It's an approximation. So you're going to go 1, 2, 3, and down 1. So let me put I have 1, 2, 3, 1. I'm going to put my circle there. That's my center. Okay. And then from there, what am I going to do? Maybe if I make it a little thicker, it'll be easier. There we go. That's a little easier. Made it a little thicker. Now I'm going to estimate. I'm going to count approximately 3.5 up. I'm going to count up 1, 2, 3. I'm going to count to the right 1, 2, 3.5. To the left 1, 2, 3.5. Down 1, 2, 3.5. Now, and then I'm going to connect my circle the best way I possibly can. So my radius, I'm going to label my radius as the square root. I'll make that one thinner though. All right, so I'll label that radius as the square root of 12. All right. Now, the next two problems you're going to try for homework, but I just wanted to show you this. Be careful of the order this is written in for number 4. Look at that order. X is second. Y is first. Make sure you take that into consideration because H is always being subtracted from X and K is always being subtracted from Y. So 3 and 4 are part of your homework assignment tonight. All right. Now let's go down here to write the equation of the circle. Now, we're going to be given different information here. So in 5, it says write the equation of the circle whose center is 5, negative 3, and it goes through to 5. Now, the center is very valuable because right when I see 5, negative 3, I know that is my H and my K, okay? And in order to actually have the equation of the circle, the constant values are your center and your radius. That point on the circle varies, so that is what X and Y is represented by. So I need to use this 2, 5 to help me find my radius. All right, guys? So I need to use that to help me find my radius. Now, I think of that equation. Your equation is X minus H squared plus Y minus K squared equals R squared. You're going to plug that 2, 5 in for X and Y because the point on that circle varies. It will not always be 2, 5, but 2, 5 can help us find the distance between the center and a point on the circle, and therefore we know the radius. So if I plug in my values, I have X minus H, which is 5 squared. But wait a minute, what can I put in for X? I just told you. I didn't write it. I'm going to plug 2 in for X. Plus Y, what am I going to plug in for Y? 5 minus K, which is a negative 3 squared. And that's going to be equivalent to my radius squared. Well, 2 minus 5 is a negative 3. Negative 3 squared is 9 plus 5 minus a negative 3 is 8. 8 squared is 64. That's equivalent to R squared. Well, then R squared is 73. Now, if I was finding R, I would know that R is the square root of 73. But if you look at your equation has R squared in it. So I'm going to actually use the 73 that I found. So my solution will be X minus 5 squared plus Y plus 3 squared, because I'm subtracting that negative 3, equals R squared. And R squared we know is 73. That would be my final solution. All right. Now, X and Y, we don't want to put that 1 point in because that's only 1 point on the circle. We have infinite points on the circle, so we leave the X and Y variables there because that point varies. All right, guys, now let's take a look at 6. Now we're going to write the equation of a circle whose endpoints of the diameter are negative 4, 1, and 4, negative 5. Now let's remember the two most important things that we need when we are writing the equation of the circle are the center and the radius. So I need to use what I'm given to figure this out. Now, if you are given the diameter, we know the center will be the midpoint of our diameter. So I can use my midpoint formula to find my center. So if I use my midpoint formula, I take the average of my x's and the average of my y's, and I get my center. So -4 plus 4, that's 0 divided by 2 is 0. 1 plus -5 is -4. -4 divided by 2 is -2. This now is my center. That's my HK. All right, guys, so now we have our HK. Now I need my radius. Now there's two ways you can do it. You can either use your distance formula to find the length, or just go back to our equation of a circle, which I think is the easiest method. So I'm going to go back to x. So here's the thing. If we use that x minus h squared plus y minus k squared equals r squared, I can solve for r. Pick one of the points that's on the circle. The diameter, the endpoints of the diameter gives you 2 points that are in the circle. You only need to work with one now because we have the center. So I'm going to pick that -4, 1. And I'm going to plug -4 in for x. H, I'm going to plug 0 in for h. Plus y, I'm going to put 1 in for y. Minus a -2 in for k. And solve for r squared. So -4 squared would be 16 plus 1 minus a -2 would be 1 plus 2. That's 3 squared is 9. That would be equivalent to r squared. So if I take a look at that, I know that 25 is equivalent to r squared. And if I wanted to know the radius would just be 5. But in my equation, I just needed to know that r squared. That's all I needed to know in that equation, right here, that r squared. All right, guys? So I'm trying to highlight it, but it's not letting me right now, guys, and I don't know why. All right, so we take a look. So that's what we needed. There we go. So now I can write the equation. Now remember, the equation, we use x and y to represent every point on the circle. We use h and k to represent the center and r to represent our radius, and it has r squared. So if I write this out, I'm going to have x minus 0. So I don't have to even put x minus 0. If I have a 0, it's just going to be x squared. X minus 0 is x, so I have x squared plus y minus a -2, which is a plus 2. That would equal r squared, which is 25. So that would be my final answer to number 6. All right. Now, what you're going to do for homework tonight, guys, is you are going to finish. You have to do 3 and 4 on that, and 7 and 8. Those are your 4 problems that you need to complete for homework tonight. I hope to see you at office hours if you have any questions. The office hours are posted below. I hope you guys have a great day, and I hope to hear from every one of you soon. Bye, guys.